Hi, welcome to the solution video for the STEP Support Programme Foundation Module 21, where we're dealing with sketching graphs involving modulus signs and inequalities. So there's quite a lot to be considering here. But actually, before we even start on any of the individual parts, I have the hint that you'd like to be considering boundaries. So for example, for part I, you'd like to consider, to start with, the modulus of x plus the modulus of y is equal to 1. And then you can test a couple of points to see whether you want to shade the inside or the outside of this boundary. So this will make a lot more sense when we go to tackle the question, and it's actually quite similar to the method you use to solve quadratic inequalities, where you first set it equal to 0 and solve for the roots, and then you test some values to see which bit of the graph you'd like to solve, to shade, sorry. So anyway, let's start with part I, and as I said, let's consider first the modulus of x plus the modulus of y is equal to 1, and let's solve just so we have like kind of the outline of the graph. So let's rearrange this to be y is equal to something, as those are the graphs that I think we'll be most comfortable with. So we want, or the modulus of y in this case, the modulus of y is equal to 1 minus the modulus of x. And this is actually in the form y equals mx plus c, which we'll kind of come into later, or the modulus of y equals m modulus of x plus c. So let me very quickly draw some axes, and we're actually going to want to be considering positive x, positive y, negative y, all separately. So let me have a y, let me have a, if I just go back to the paintbrush, a y here and x here. Let's first consider the top right quadrant, so that's going to be x is greater than 0, or x is greater than or equal to 0, y is greater than or equal to 0. So top right. And here we have the modulus of x, where x is positive, is just x. The modulus of y, where y is positive, is just y. So y is equal to 1 minus x. And using y equals mx plus c, we have a gradient minus 1, y-intercept is 1. So we should just be able to draw this on the graph if I get a line tool like this. Okay, so this is, I might as well draw some numbers on here actually as well, which is quite helpful. Just, I think in general with graphs in STEP you want to label any important points, so that is mostly axis intercepts, turning points if they matter. And yeah, let's just continue filling in each of the quadrants. Remember, we can't extend this line, it's only for this top right quadrant, as the equation does change. So let's now do the bottom right quadrant. And here we have y is negative and x is positive. So we have minus y is equal to 1 minus x, setting x to be positive, y to be negative, which if we negate the whole thing, we get y is equal to x minus 1. And again, just using y equals mx plus c, to get an idea of where this line goes, we'll find that it's somewhere like this. And I'm actually doing these lines solid because the inequality is less than or equal to inequality. So we don't do them dotted. Yeah, let's just continue on like that. And let's do bottom left quadrant. And we have here y and x are both negative. So we set modulus of x to be minus x, modulus of y to be minus y. And that leaves us with minus y is equal to 1 plus x, because it's a minus of a minus. So then negate both sides, we get y is equal to minus 1 minus x, which gives us the exact same situation. And we can draw it on something like this. Okay, getting there. Last one left. So we've got a minus 1 here. And yeah, we're just left with the top left quadrant. So here we have x is negative, y is positive. So that leaves us with y is equal to 1 plus x. So that gives a y-intercept of 1, gradient is 1. So that's something like this. So we have a kind of cube on its side, like a diamond, Now we're not done, remember, we need to consider where we want to shade. So are we shading inside, are we shading outside of this diamond? And we actually have to consider each of these quadrants separately, because the equation is changing in each of these. So we might have a minus y in one, a plus y in the other. So anyway, the way we're going to consider it is, say, let's take the point 1, 1 here, which lies outside of the diamond, and we want to substitute this into the equation and see if it satisfies it. So let's add kind of here, testing 1, 1. We get the modulus of 1, substituting in x equals 1, plus the modulus of 1, substituting in y equals 1, is equal to 2, which is greater than or equal to 1. So that doesn't satisfy the equation, it's not less than or equal to 1. Sorry, I should say greater than 1. So this point is not in the inequality, which means that the other side of the line must be. So we want to be shading this bit of the line. And if we did find that it was in the inequality, so that this did satisfy the equation down here, then we'd want to shade all of this instead. So we want to be shading one side of the line or the other. Okay, now let's consider the bottom right quadrants. Let's again consider 1, minus 1 now. Scroll down a bit. So testing 1, minus 1. We get the modulus of 1, that's the x, plus the modulus of minus 1, that's the y, is equal to 2, which again is greater than 1. So that doesn't satisfy it again. So you might be seeing how this is going, but we do need to do it all still. We need to be shading this bit. Let's just, for the sake of varying things up a bit, try something different for the bottom left quadrant. Let's do a point about here. So that could be, say, minus 0.5, minus 0.5. So let's say bottom left, testing minus 0.25, sorry. Minus 0.5 would lie on the line. Minus 0.25. We get the modulus of minus 0.25 plus modulus of minus 0.25 is equal to 0.5, because both of those are negated, they're made positive, which is less than 1, less than or equal to 1. So it does satisfy the inequality. So we are completely fine to shade this bit that the dot, the point we chose, lies in. Okay, last bit. We have y is equal to 1 plus x. Sorry, this is the top left bit of the inequality. So let's again test a point outside. So we have, let's say, x equal to minus 1, y is equal to 1. So we have the modulus of the x plus the modulus of the y is equal to 2, which is not less than or equal to 1. It's greater than 1. So we don't want to shade this bit, we want to shade this bit. And there we go. We've shaded each of the 4 quadrants. We get a nice diamond with the inside that's shaded. And that's the first part of the question done. So now for the second part. I actually put these both on the same slide, as they do look quite similar, don't they? The only difference is we've replaced an x with an x minus 1 and a y with a y minus 1. So this is actually a translation, and I think you might just be able to see this straight away, which is completely fine. A way to think about this might be to substitute values in. So for example, if we consider the point where, say, this point in our part I, where x is equal to 1, y is equal to 0, what's that going to be in part II? Well, we want this bit to equal 1, so we want x to equal 2. And we want this bit to equal 0, so we want y to equal 1. So let's say y equals 1, x equals 2. Okay, so you can see that we're kind of adding 1 to both y and x. And if you test a couple of other points, if you're not quite satisfied with that, I think that might be enough to convince you that it's just a linear, we're linearly mapping it to kind of translate the graph by the vector. So, translation by 1, 1. So i.e. we're shifting it in this direction. So the only difference is, and I think I'm not going to try, actually I might try to just draw the outline of this on top. We want to move the x across by 1 and the y across by 1 to get something like, if I just draw it with a line, this. Oh, actually no, we want to shift the y across by 1 as well. Get something like this. Oh. There we go. So again, I haven't drawn it properly, and you would draw it on a separate graph in the question, but just for the sake of demonstration. And the shading will be exactly the same, because it's just the same graph that's been translated. We can shade just the inside bit, and that's completely fine. And I've actually, from the solutions document, copied over the graphs that have been kind of put up on by computer. This is part I's graph, exactly the same as what we got, and this is part II, where they've shifted it to the right and upwards by 1. Okay, now let's try part III. Well, actually, the only difference again is we've got a -1 here, so that's just a difference in the translation, I guess. And we've got a minus sign here. I'll just switch back to blue. Yeah, we've got a minus sign here. So I think that's going to be the main bit we want to consider. And actually the last part kind of part II taught us that we don't need to worry that much about translations. So anything inside this modulus, we don't need to worry about like y plus something, x minus something. We can deal with that later. So let's first consider, just to kind of make it as simple as possible, then we can deal with the complex things later. The modulus of x minus the modulus of y is less than or equal to 1. And then we can go on to consider the translation, which should just be translating the x, translating the y, exactly what we did last time. Okay, so again we're going to just consider the boundary first. So the modulus of x minus the modulus of y is equal to 1. Let's rearrange to get modulus of y is equal to modulus of x minus 1, I believe. Yeah. And okay, now what do we want to do? We want to consider each of the 4 quadrants again. So let's do the top left quadrants, where x and y are greater than or equal to 0. We have y is equal to x minus 1. Let me draw some axes very quickly so we can get that on. Might move that a bit to the side. Slowly. There we go, that's probably the best I'm going to get. So, okay, this is again y equals mx plus c, the form, which can help us out. We have the y-intercept as -1 and the gradient of x as 1. So, okay, this is for the top left quadrant actually. So, we would like it to be going something like this, but only for the top left quadrants. So I'm going to try my best to delete this bit in the bottom left quadrant. Oh, whoops. There we go. Yeah, perfect. And let's, of course, label on some numbers. This is a 1 here. And that does just keep extending onwards. So I might just do ... to show that. Okay, now let's keep going. We want the bottom right. Oh, sorry, that was the top right quadrant. Yeah, so bottom right quadrants. This is where the x is positive and the y is negative. So we want minus y is equal to x minus 1, which gives y is equal to 1 minus x. Okay, let's think about where this line is going. The y-intercept is 1 and the gradient is -1. So again, we're just going to be like following it down like that, and then it's going to continue downwards. So let me just draw that on as a bit neater, like that. And then of course that continues on. Not the best graph, of course, but that's completely fine. It's just a sketch. As long as you're using a ruler and a pencil, ideally, that should be fine. Okay, now let's consider bottom left. Did not mean to do that. There we go. So here we have both of them are negative, so we have minus y minus x, is equal to minus x minus 1, or y is equal to x plus 1. And again, this is kind of symmetrical with what we had before. It makes sense where we have the y-intercept as being 1 and the gradient as being 1. So we can kind of follow it from here down. But of course, we only want to consider the bits in the quadrants that we're considering. So we delete all of that. Okay, getting there. Now we want the top left quadrants, where we have y and x are both, y is positive, x is negative, so y is equal to minus x minus 1, which we don't have to rearrange, we just have the gradient is minus 1 and the y-intercept is minus 1. So that's something like this. And again, I'll draw on where the axis intercept is here. We have a minus 1 there. Okay, so again, we just need to consider in each of these 4 quadrants whether we want to be shading this bit, so the bit kind of, I suppose, towards the centre, or this bit, the bit outside of the centre. We're going to be shading one of the sides of the lines, effectively. So top right quadrant, let's consider the point, say, 1, 1. So I haven't left myself much space, sorry. 1, 1. We have the let's use this equation here. Because again, remember, we're not considering the one in the question yet. We have translated it kind of away from that. So substituting x is equal to 1, y is equal to 1, we get 1 minus 1 is equal to 0, which is less than or equal to 1. So 1, 1 does lie inside this range, so we can shade that in. There we go. So it's that side of the line. Bottom right quadrant, we want to consider, let's say, 1 minus 1. So consider 1 minus 1, and we have the y is minus 1, oh no, sorry, okay, the modulus of x, 1, minus the modulus of minus 1 is equal to, let's say, 0 again, because it's 1 minus 1, which is less than or equal to 1, so it satisfies our equation, because it satisfies this right hand side here. So okay, let's shade that one. Okay, let's now maybe, why not consider a point outside the other side of the line. So it's kind of hard to come up with that actually. Let's say minus 2 minus 0.5. I think that works just from looking at our diagram. This is why it's always so helpful as well to draw a diagram like mid the question. Don't try to sketch it all at the end. Kind of add bits to your sketch over time. And if you really need to, you can sketch it again if it gets messy. I just think it helps me visualise it. So let's consider minus 2 minus 0.5. So we have the modulus of minus 2 minus the modulus of minus 0.5 is equal to 2 minus 0.5, which is equal to 1.5, which is greater than 1. So it doesn't satisfy our inequality. So we want to be shading the other bit, which is kind of symmetrical with what we found so far, so it makes sense. But we do need to be considering these still individually. Last one, I think probably the minus 1, 1 is simplest. So let's do that. For the top left quadrants, consider minus 1, 1. And we get the modulus of minus 1 minus the modulus of 1 is equal to 1 minus 1 is equal to 0, which is less than or equal to 1. So it satisfies the inequality. So that leaves us with the last shaded bit like that. And of course it's very tempting to just say that we're done now, but we're not. We need to deal with the translation in the question, where we have x minus 1 and y minus 1. But that should just be the same as dealing with II last time, which really didn't take us that long. So we just noticed that, and again you can substitute in numbers or look at the previous part if you need to convince yourself of this. But this is just a translation. of what we've just drawn by 1 minus 1. Okay, so now we can sketch that probably on a new diagram. I might just do kind of a very rough one and then I'll show you the solution on the next slide. So if we've got this big y, this big x, probably shouldn't have done it this small, but we move the whole thing to the right by 1 and down by 1. So that should be something like, to the right by 1 does this, down by 1 as well. And then we shade, not the outside bit, but the inside bit is what we shade is exactly the same, even if we just translate it. Let's have a look at the nicely drawn one. Yeah, and we've got the orange line is what we initially drew, and then the translated version is the pink one, where we've kind of moved it down and to the right. Perfect. So that's the third part done. Now we're just on part IV. Of course, getting tired of this now, but not much left to do. And again, I think we'll just consider it exactly the same way we considered III. We've got a multiplication instead of an addition or a subtraction, but I don't see any reason why our method wouldn't work, so let's keep trying along with it. So let's first consider the untranslated one, where we've got the modulus of x, modulus of y, it's less than or equal to 1. And then let's consider the boundary, so the modulus of x, modulus of y is equal to 1. And now let's consider each of the 4 quadrants again. So for the last time, we've got the top left quadrants, where we have x and y both positive. Again, top right. You can tell I'm not the best with my lefts and rights. So top right quadrant, we have x and y both positive, so we have xy is equal to 1, which means that, again, just rearranging for y, we have y is equal to 1 over x. Note that this is only true for x is not equal to 0. It might be worth writing that on. But we're just considering kind of the top right quadrant. I think we can join it up or see if it touches it or anything. So let's just see what happens. But we know we're not considering the axis here, if that makes sense. And actually, we've seen this graph before. It's a reciprocal graph. So of course, we just want to be considering the top right quadrant of it, but we've seen that before. But yeah, and let's draw some axes very quickly. Okay, and back to brush tool, we've got a y and an x, and yeah, y is equal to 1 over x in the top right quadrant. And of course, x wouldn't equal 0 in this graph anyway, so I'm quite happy we can just leave it at this for now. Okay, bottom right quadrants. So we have, again, now we've got the y is negative, so that's gives us minus xy, because we have the modulus of x times the modulus of y is equal to 1, which gives us that y is equal to minus 1 over x. Okay, and again, x is not equal to 0. You probably don't have to write it on at this point, but I think it just helps to, because we can't divide by 0, that is. So y is equal to minus 1 over x. Well, y is equal to, if we just, we can't consider y equals mx plus c anymore, but we can consider, this is our reciprocal graph of y is equal to 1 over x. And if I write in another colour, green, y is equal to minus 1 over x. We have this and this. So of course we're just considering the bottom right quadrants, so we just consider this bit to the bottom right there. And it gives us a nice and symmetrical shape of this. Okay, so the other parts actually aren't going to take as long as you might expect, or as long as they did before. So if we do bottom left, then we have minus y times minus x, because they're both negated by the modulus signs, is equal to 1. So yx is equal to 1, so y is equal to 1 over x, which again we know. So we can just sketch that on like this. because it's just the bottom left quadrant. And finally for the top left, we get the y times minus x, because x was negative, y was positive, is equal to 1, which gives minus yx is equal to 1. So y is equal to minus 1 over x, as we've already seen, which we drew in the green here. So that's top left quadrant, so we can just copy that over like that. So it's really exactly the same process as we did for I and I. Just with a reciprocal graph now instead of kind of nicer y equals mx plus c's. So now, exactly as we did before, as the questions kind of guided us to do, let's test some points. So let's start by testing, say, okay, I don't want to kind of mistakenly test 1, 1, because that will just lay on the line. That won't tell us anything about what we shade and what we don't. So let's say do 2, 2, just to be safe. And remember, we're not testing this translated version, we're testing this version. We want the inequality, this one. So okay, top right, we want x is equal to 2, y is equal to 2. Let's test test 2, 2. When we get the modulus of 2 times the modulus of 2 is equal to 4, which is greater than 1. So that doesn't satisfy the inequality, so we want this bit. The bit's the other side of the line. Okay, and let's just kind of repeat like this. I'll go through quite quickly because we've already done this a few times. Let's do 2 minus 2. So 2 minus 2, where we get the modulus of 2 times the modulus of minus 2 is equal to 4, which again is greater than 1. And you can see, like, if we're doing plus minus 2, whatever we test, it's going to give us that it doesn't satisfy the inequality. So I will just go through them very quickly. Bottom left, we'll do minus 2, gives us the modulus of minus 2, modulus of minus 2. Just by substituting this into the equation, is equal to 4, which is greater than 1, so it doesn't satisfy it again. And top left, we have points. I'll just draw it in the diagram actually. So yeah, we just tested this one, we want to test this one. At the top left, we have x is equal to minus 2, y is equal to 2. So that's minus 2, 2. So we get modulus of minus 2 times modulus of 2 is equal to 4, greater than 1, doesn't satisfy the inequality. So we're left with this region. And we've got one more thing left to do. We're on the home stretch, where we just want to translate just the y this time, which is quite nice. And again, there's no reason why it shouldn't just be a translation. If we kind of test out some values, say what used to be y is equal to 4, in modulus of x, modulus of y is less than or equal to 1. So y is equal to 4 here, we're going to need a 6 here, and it gives the exact same value as it did. So we're just adding 2 to the y. So let's translate by 0, 2. And again, I will spare you my drawing of that and show you the answer, like the solution, where we have exactly what we had, but just shifted it up by 2 in the y. And that's the graph. So it was a lot of kind of algebra to get through it, but we have sketched 4 different graphs, kind of maybe a bit more simply than you'd expect from looking at those equations. Yeah, bye.